Dear students, this is the first session of heat power engineering. The another name of the subject is thermal engineering. Thermal engineering is the name which is frequently used in dealing with the subject. In this session, the topics are going to be covered are introduction to the thermodynamic system, boundary, and surroundings. Introduction. Dear students, in your daily life, you are coming across different devices like gas stove, pressure cooker, refrigerator, air conditioner, thermo flask, automobile vehicles, locomotives, thermal power plants, nuclear power plant, jet engines, etc. What the thing we are noticed over these components either generates the heat energy or these devices operated by the heat energy. Gas stove generates the heat energy, pressure cooker absorbs the heat, refrigerator extracts the heat, air conditioner maintains the heat or temperature, thermoflask maintains the temperature, automobile vehicles generates the heat, in turn convert that into the useful work. Locomotives also generates the heat that will be converted into the useful work. Thermal power plants, the chemical energy will be converted into the heat energy that in turn converted into the electrical power. Nuclear energy also used to convert that nuclear energy into the electrical energy and so on and so forth. See, these devices are operated by heat energy. See, heat energy is the new concept. If it is so, what is the old concept of the heat energy? The old concept of the heat energy, the people had thought that it was a fine, invincible fluid filling in the pores of the substance. When the hot body and cold bodies are bring in contact, the heat, that invincible fluid, that means what that invincible fluid flows from hot body to cold body as well as cold body to hot body. But that heat fluid flow to hot body to cold body, it is the wrong notation. As the science evolved, the picture of the heat as a fluid was discarded in favor of the modern concept of the heat is a form of energy, right? So, as we know, energy is capacity to do work. The rate of work done or the rate of energy is called the power, as we all know, right? See, if it is though, what is the correlation between the working of those devices and the thermodynamics? It's a very simple. The definitions of the thermodynamics is the correlation between the working of the thermodynamics devices and the thermodynamics. Okay, there are many definitions of thermodynamics. So one of the definitions of the thermodynamics is like this. Thermodynamics is a branch of physics that deals with the concept of the heat and temperature and its conversion or interconversion of the heat and other forms of energy. I repeat, thermodynamics is branch of a physics that deals with the concept of the heat and temperature and interconversion of the heat and other forms of the energies. See, as you know, that are the other forms of the energies are what? Electrical energy, chemical energy, etc. The another different definition of thermodynamics is thermodynamics is a branch of science which deals with the relationship between the heat and work and other forms of energy. It describes heat energy converted to and from the other forms of energy and how it affects the matter. Okay, as I told you, these definitions establish the correlation between the working of those devices, that is the thermodynamic devices, and the thermodynamics. Okay, uh, to study this, to study this, basically there are two types of the studies in whatever may be the subject or whatever may be the course. That's a macroscopic study and microscopic study. In the macro, okay, very first, thermodynamics is a macroscopic science. If it's so, what is microscopic science? Microscopic science means studying of the working substance of its construction, its molecule, movement of the molecules, its atom, its movement of the electrons, etc. etc. These are all coming under the microscopic study of that subject. But thermodynamics deals with the bulk system, does not go into the molecular constitution of the matter. In mechanics, the motion of the particles or the bodies under the action of the forces, whereas thermodynamics is not concerned with the motion of the system as whole, it is concerned with the internal macroscopic state of the body. That means what? Thermodynamic system will not have any motion. It will not move from anywhere to anywhere, from here to there, there to here. But it is the concerned with the internal macroscopic. See, what the working fluid is there inside the thermodynamic system, we are taking only the macroscopic point of view. We are not going to the molecules, movement of the molecules, or the atoms, or the movement of the electrons. See, that means what? What the study we are going to study the thermodynamics. The thermodynamics is a macroscopic science. Thermodynamics is a macroscopic science. Okay, to conduct the study or to deal with the subject, some entities are required. The basic entity to study the subject, to analyze the subject, is thermodynamic system. See, before going into the definition, I'll try, I am trying to get you to make out what exactly the thermodynamic system. Okay, thermodynamic system consisting the matter, sorry, thermodynamic system consisting of matter, boundary and surroundings all together form a thermodynamic system. It's not yet over. Thermodynamic system, it's a definite space with some matter. Definite space means what? It has to have its own volume, and then that volume has to be filled with some matter. And boundary means what? An envelope covered that matter. And surroundings, some components or the things or the entities outside the boundary are called surroundings. And so this is the things we have to be noticed over here are described by the state of the variables. See, thermodynamic variables. In the beginning, I would like to say which are the thermodynamic variables: temperature, pressure, volume, internal energy, intrinsic energy, enthalpy, entropy, specific heat. These are all the properties of the thermodynamics. But at present, let us take on to only the three basic properties of the thermodynamics or state of variables of the thermodynamics: temperature, pressure, and volume. The remaining concepts will be studied in detail in the future classes. Okay, it's a definite space with some matter, boundary, and surroundings, and described by the state of the variables like temperature, pressure, volume, etc., and whose thermodynamics is studied. This is the thermodynamic system. Okay, to understand it better, I'll take this I'll consider, actually, this is a thermodynamic system, right? According to the definition, it should consisting of some space. Okay, this is the space. What? The portion inside this flask or metal casing is the space. It's a definite space. Why we are calling it as a definite space? Because it's a covered. It's having its own volume. That's what we are calling it as a definite space. Covered with an envelope. It is covered with a metal casing. And it is having the surroundings all around. I'll take any one of the components beside to this, right? All together form a thermodynamic system. Then, how this thermodynamic system is described? Okay, a thermodynamic system is described by these three normal variables. These three normal variables. Right, very first one, temperature. Consider this thermoflask is filled with the hot water, right? The hotness of that water defines or describes the state of the system. I repeat, if I fill the cold water into this specific space or definite space, that coldness of the water defines the state of the system. This is how the temperature describes the thermodynamic system. Pressure. As we all know, the atmosphere is having some pressure. Because it is open to the atmosphere, its pressure is nothing but equal to atmospheric pressure. Then that pressure describes the state of the system. So what is the pressure of the system? The pressure of the system is atmospheric pressure. This is how pressure also describes the state of the system. Next, volume. As I told you, it consisting of a definite volume. Any space whose volume can be measured. That's a specific volume. That means what? It consisting of a liter of fluid or of a liter of matter. That means what? This volume also describes the state of the system. I repeat now the full definition of this thermodynamic system. It is a definite space with some matter, boundary and surroundings and described by the state of the variables like temperature, pressure, volume, etc. and whose thermodynamics is studied. This is called the thermodynamic system. This is called the thermodynamic system. Next, boundary. I did tell you. Before this, I did tell you, or I was telling you, the matter is covered with, or the space is covered with the metal casing. You're noticing this is a real boundary. It's a real boundary and it's made out of a metal. Is it necessary all the time the boundary of the thermodynamic system is real one and solid one? For this question, answer is certainly not. Certainly not. That means what? It doesn't mean that the boundary of the thermodynamic system should always a real one. It may be imaginary one. It may be imaginary one. Okay, I'll take this late. I'll take this late. I'll consider it a thermodynamic system. It's consisting of the volume. It's a solid one. That solid is consisting of the volume. It is having its own temperature. The pressure, because it is exposed to the atmosphere, it is consisting of the atmospheric pressure. But the boundary of the system, if I define, it is not having any boundary. That means what? It is consisting of the imaginary boundary. Okay. From this description, what we have learned here, the boundary either may be a real one or imaginary one. Further to this, further to this, the boundary does not be fixed one. That means what? All the time the boundary should not be a fixed one means what? It is a definite one. See, it's a movable. The movable boundaries are there. See, you take a tube of a tire or a wheel of the vehicle. When you goes on filling the air is nothing but the matter you are filling in that. If I consider the tube itself a system, that boundary goes on increasing. That means what? It's a consisting of the flexible boundary. Or else, the movement of the piston inside the cylinder of an IC engine is an example of the flexible boundary of the system. The boundary will not be remaining constant. It moves as the pressure increases and moves down as the pressure decreases. That means what? In all the time, the boundary of the system should not be a fixed one. It may be flexible one. Mathematically, the boundary has no thickness. If it's an imaginary one, means what? It quite nature, it does not have any thickness. Then if it's an imaginary one, it's quite natural, it does not have any mass. In the same way, if it's an imaginary one, it doesn't have the thickness. That means what? It doesn't have any sort of the volume. Okay, I repeat, the real or the imaginary surface of that separate the system from the surroundings. The boundaries of the system can be fixed or movable. Mathematically, the boundary has zero thickness, no mass, and no volume. Okay, last part of the session, surroundings. Anything outside the boundary of the system are called the surroundings. Anything outside the boundary of the system. Okay, this is the system. This thermodynamics properties are studied regarding the system. Okay, it is another component beside to this. Okay, if I consider this is the system, then this will become the surrounding of the system. This will become the surrounding of the system. Okay, that monitor is the surrounding of the system. This keyboard is the surrounding of the system. It doesn't mean that all the time or always the surroundings have to be a solid ones. There may be a liquid ones or there may be a gas ones. Finally, the system plus boundary plus surrounding or atmosphere all together forms the universe. At the end of this session, I summarize like this. Heat power engineering or thermodynamics is a branch of science which deals with the heat and mass and conversion of the heat into the different forms of energy, that conversion of that energy into the different works. Right? Based on this principle, many more thermodynamics devices are constructed. These devices are gas stove, refrigerator, thermoflask, internal combustion engine, locomotive engine, nuclear power plant, etc., etc., etc. That means what? Heat is a form of energy. This is a new concept of the heat, but the old concept of the heat was people had thought that the heat is a fine, invincible fluid that filled with the pores of the substances. When hot and cold bodies bring in contact with each other, that Invincible fluid flows from cold body to hot body and hot body to cold body. As the science evolves, as the science evolves, it has been derived that heat is a form of energy. That energy is capacity to do work. The study of thermodynamics is a macroscopic study. Here, we are not going to study microscopically, we are studying only the macroscopically. To conduct this macroscopic study, a basic entity is required. That entity is the thermodynamic system. Thermodynamic system means what? A matter covered with a boundary and surroundings all together form a thermodynamic system, and this system will be described by the thermodynamic variables like temperature, pressure, volume. Right. A boundary either it's an imaginary one or solid one or real one. It doesn't mean that all the time the boundary has to be a real one or solid one. It may be imaginary one, and the boundary may also be a flexible one, and the boundary will not have any mass and no thickness, and anything outside this boundary or the boundary which separates the surroundings and the matter, or the surroundings means what? Anything outside the boundary of the system or thermodynamic system are called the surroundings. Finally, the conclusion is this: system plus boundary plus surroundings all together form the universe. With this, I am concluding this lesson. Thank you.